Welcome to our presentation on effect of T-consciousness fields on the growth and production of ATP in E. coli BL21 under microgravity and Earth gravity conditions. My name is Fateme Barancheshme and I am delighted to have you join us as we explore this fascinating intersection of consciousness, biology, and space. Firstly, I would like to recognize our research team, Muhammad Ali Taheri, Zahra Haj Ibrahimi, Sara Torabi, and Farid Semsarha, whose expertise have been instrumental in shaping this research. Without further ado, let's dive in. The table of contents is available for your reference. But let's dive right into the heart of our presentation, objective and introduction. The goal of this study is to explore the effect of T-consciousness fields on E. coli growth and ATP production under microgravity and Earth gravity. But what are the T-consciousness fields? T-consciousness fields were introduced by Muhammad Ali Taheri in 1980s, proposing them as non-material, non-energetic elements with distinct functions within the cosmic consciousness network. TCFs are hypothesized to affect all entities, including microorganisms, with practical applications across various domains. Why E. coli? Microorganisms, including bacteria, play a crucial role in Earth's biosphere, and their presence extends far beyond our planet, even into space exploration, highlighting the importance of comprehending their behavior in a space habitation environment. Moreover, bacteria demonstrate remarkable resilience, like showing adaptability to extreme conditions. E. coli in particular has garnered extensive attention as a model organism due to its notable physiological responses and gene expression modifications observed under microgravity conditions. This is why E. coli was chosen as the focus of our research. Now, let's transition into materials and method sections and details around procedures and materials employed in our study. During this study, we applied 3 types of TCFs to E. coli BL21 strain, following the protocols outlined by Cosmo-Intel. Accessing and applying these TCFs was made possible through a sign announcement section on the Cosmo-Intel website. Throughout the experiment, TCFs were continuously applied to the bacteria for a duration of 24 hours. Notably, the entire experiment was conducted using a double-blind method. This ensured that the lab technicians remained unaware of TCF theory, while the individual applying the treatment remained uninformed about the study's specific details. The experiment consisted of 4 distinct experimental groups. Group 1 under microgravity and TCFs application, Group 2 under microgravity without TCFs, Group 3 under Earth gravity with TCFs, Group 4 under Earth gravity without TCFs. This design allowed for a comprehensive comparison to assess the effect of TCFs applications under both microgravity and Earth gravity conditions, with appropriate control groups for accurate evaluations. As for our measurement parameters, we looked at a couple of key factors. Firstly, we assessed E. coli's growth rate using optical density measurements. Additionally, we measured ATP production through luciferase enzyme activity. ATP, as you know, gives us an insight into the metabolic activity of the bacteria. In our experimental setup, as you can see in these photos, we arranged 6 syringes and petri dishes in the clinostat. 3 of these samples were subjected to TCFs for a duration of 24 hours. We maintained a rotational speed of 30 rpm for liquid mediums and 15 rpm for solid mediums. Similar procedures were followed for untreated samples, serving as controls to ensure consistency across our experiments. The clinostat served as a reliable tool for replicating space experiments under real microgravity conditions. Shifting our focus to the results and discussion section, we will explore the outcomes of growth of bacteria and ATP production measurements. Bacterial cell growth measured by OD600 for samples under the influence of TCFs and their control in both Earth gravity, and microgravity are shown in these bar and box graphs. The results showed that the microgravity environment increased bacterial growth up to 1.4% compared to the 1G condition, while under the influence of TCFs, there was no significant differences between samples in microgravity and Earth gravity. In other words, microgravity conditions significantly induced bacterial growth, and treatment with TCFs inhibited this trend. Additionally, the growth of bacteria reduced under TCF's treatment in both microgravity and Earth gravity conditions. In comparison with the control, TCF's treatment reduced the growth rate by about 2.4% under normal gravity. In these bar and box graphs, the changes of ATP concentration under the TCF's treatment are compared to the control samples in microgravity and Earth gravity. During the analysis, it was observed that applying TCFs increased the concentration of ATP by around 2 times in Earth gravity. However, the changes under microgravity environment was not significant. Interestingly, the observed enhancement in ATP production under the influence of TCFs is in line with previous studies in another experiment on egg cells. Moreover, our experiment of bacteria cultivated in microgravity revealed approximately 4 times lower ATP concentrations, implying that bacterial strains operate much more efficiently under microgravity conditions. In conclusion, this study confirms the distinct effect of TCFs. These non-material and non-energetic fields exert varying influence on the behavior of E. coli under both microgravity and normal gravity conditions. Notably, TCF's treatment effectively counteracted the inducing effect of microgravity on bacterial growth, while remarkably enhancing ATP concentration under normal gravity conditions. These findings underscore the potential of TCFs in modulating biological processes and uphold promise for applications in diverse fields of research. Here are some of the references we use in our study. Feel free to explore these resources for more in-depth information on our research background and methodology. Lastly, here are the names and contact details of our dedicated research team. Please feel free to reach out to any of them if you have further questions or would like to discuss our findings in more detail. Thank you for joining us today. If you have any further questions or would like to connect, please don't hesitate to reach out. Here is the contact information for Cosmo Intel. We extend an invitation to laboratories and research institutions for potential collaborations opportunity. Thank you once again for your time and attention.